The motivation for this project was to provide students in an urban district with an opportunity to be able to engage in real-world engineering design that is integrated into their science curriculum. By integrating technology-rich engineering experiences in the science classroom, students can see the relevance of science and math to solving real-world problems. This can increase their motivation to learn as well as their interest in math and science.
Our collaboration between the University of Akron, Akron Public Schools, and the Soapbox Derby allowed us to pose an authentic problem to 1,500 8th grade students across the district. Can you redesign the Soapbox Derby car to make it go faster? In order to solve this problem, students worked with the mini car as they learned about engineering concepts such as prototyping and optimization. They investigated how different car shells go down a track in their classroom and tested these shells in a wind tunnel to calculate drag values. As students gathered data from their investigations, they learned concepts of aerodynamics, force and motion, and kinetic and potential energy, which allowed students to connect science concepts to the engineering problem.
We introduced the idea that students are filling their engineering toolkit to give them tools to help solve the problem and use the engineering design process to guide them. The next step in the process was integrating technology through the use of a virtual wind tunnel as an example of computational testing. After learning the basics of CAD, students had the tools that they needed to brainstorm solutions for their problem. They designed a new car shell in 123D Design and imported those designs into the virtual wind tunnel. They tested it, and based on those results, they went back to CAD to optimize their designs, just as engineers do. The best designs were 3D printed and tested by racing down the track in a classroom competition, as well as in the wind tunnel. Students also had a district-wide competition among 7 schools to see which designs performed the best.
Students prepared presentations about their work and shared their results with classmates. We measured the impact of the curriculum by comparing the 8th grade students who participated in the intervention to a group of 8th grade students from the year prior who did not participate in the intervention. We used established measures, including the Forces in Motion test, Engineering Concept Assessment, and STEM, to compare the two groups on their knowledge of forces in motion, understanding of the engineering design process, and their ability to apply the engineering design process to a new design problem. Preliminary results from the pilot year showed that the students who were in the intervention group statistically significantly increased in their understanding of engineering design concepts and their self-efficacy in engineering.